So for today, we're going to discuss calculus of vector-valued functions. Okay, so I recall, we have a vector-valued function. R is a function whose domain is a subset of the set of real numbers and whose range is a set of vectors. Okay, so we write R as R of t, which is equal to x of t, y of t, and z of t, where x, y, and z are real valued functions of t. So suppose r of t is a vector-valued function. We have the limit of r of t as t approaches a, which is equal to the limit of its corresponding components, provided that those limits na nakita natin dito all exist. Okay, so otherwise the limit does not exist. Okay, so we say that r of t is continuous at t is equal to a if it satisfies the following condition. For 1, we have r of a exists. For 2, we have the limit of r of t as t approaches a exists. And for number 3, we have the r of a is equal to the limit of r of t as t approaches to a. So if any of the conditions fails to hold, then r is discontinuous at t is equal to a. Okay, so let natin yung r of t as a vector-valued function. So we have the derivative of r is equal to x prime of t, y prime of t, and z prime of t, provided that all of these exist. Okay, so theorem, we have let f and g be vector-valued functions, and let f, small f, be a real-valued functions. Okay, so if f, g, and small f are differentiable, then the following hold. For number 1, we have the derivative of the sum and difference of two vector-valued function is equal to the sum and difference of the derivative of the two vector-valued functions. So yeah, so for number 2, we have the derivative of the product of a real-valued function f small f and a vector-valued function f is equal to product rule, which is small f of t times f prime of t plus f of t times small f prime of t. For number 3, we have the derivative of the dot product of two vector-valued function, which is equal to the same rule. So we have f of t dotted to g prime of t plus g of t dotted to f prime of t. For number 4, we have the derivative of the cross product of two vector-valued functions. So that is equal to f of t cross g prime of t plus f prime of t times g of t. So for number 4, be careful of its form. So this should be followed since cross product is not commutative. So, yeah. For number 5, we have the derivative of the composition of f and real-valued function small f. So that is equal to f prime of small f of t times small f prime of t. Okay, so we have let r of t be a vector-valued function. So the indefinite integral of r is given by the integral of its corresponding components. So for the definite integral from t is equal to a to t is equal to b of a continuous vector function r of t, it is given by it is given by the definite integral of its corresponding components. So yeah, for number 1, we have determine whether the vector function r of t is continuous at t is equal to 1. So to see if r of t is continuous at t is equal to 1, we shall check if the three conditions for continuity are satisfied. So for number 1, we find the value of r at t is equal to 1. So given this r of t, makita natin that if t is equal to 1, this should be its value. So yeah, we have 1, 3, 2 for number 1. For number 2, we have the limit of r of t as t approaches to 1, which is equal to the limit of its components. So yeah, for the first component, we can see na this one is indeterminate once na sinubstitute natin yung t is equal to 1 to the numerator and denominator. And we can simplify this one by certain techniques like cancellation for the third component. And yeah, so I think what we can use here is the L'Hopital rule. So we have to differentiate the numerator and denominator. Okay, for the second one, we can use the following rule. So I'm going to write it here sa gilid. So we have a limit of sine of x over x as x approaches to 0, which is equal to 1. So for this one to magagamit natin tong rule na to. First, the input of the sine of x should be equal to the denominator. So for this one, I think hindi pa siya equal. So we have here 3t minus 3 and then t minus 1 sa denominator. So for that, I think we can multiply 3 sa denominator since when you multiply 3 here, yung input sa sine function is equal na sa denominator. So that's one. And this another rule here is that x should be approaching to 0. So for this one, t is approaching to 1. And when we substitute 1 to the input of sine and then to the denominator, equal naman siya sa 0. So that's all right. So what we can do is to multiply na lang 3 over 3 para maging equal yung denominator sa input ng sine. And for the last one, what we can do here is to factor it and see if there is something that pwedeng ma-cancel. Since this one is indeterminate pa once na sinubstitute mo yung 1. Okay. So we have the following. So for the first component, yan, so then differentiate niya ngayon numerator and denominator. For the second component, we have here, ayan, yung result which is 3 over 3t minus 3. So, and for the last component, we have t minus 1 as some factor na pwede nating i-cancel. So, therefore, we have the following. So, yung derivative ng natural log of t is equal to 1 over t, while the derivative of t minus 1 is equal to 1. So, therefore, we have the following limit of 1 over t as t approaches to 1. And for the second component, we have yung 3 natin dito, pwede natin siya ilabas out of the limit since it is not a function of t. So, we have limit of sine of 3t minus 3 over 3t minus 3 as t approaches to 1. And for the last one, we have the limit of 4t plus 5 over t plus 2. So we can proceed by substituting t is equal to 1 here because hindi na siya indeterminate. Okay, so therefore we have the following. So we have 1. For the second component, we have 3 times 1 using this rule. And for the last component, we have 4 times 1 plus 5 over 1 plus 2. And therefore, we have 1, 3, 3. Okay, so for number 3, we have r of 1 is equal to 1, 3, 2, which is not equal to 1, 3, 3 as something na nakuha natin sa limit of r of t as t approaches to 1. And it is not satisfied. Therefore, r of t is discontinuous at t is equal to 1. Okay, so for problem number 2, we have to determine a vector equation of the line tangent to the graph of the vector function r of t, which is equal to the natural log of t plus 1, t minus sine of 3t, and then e raised to 2t at the point where t is equal to 0. So for the solution, recall that the vector equation of the line through the point x sub 0, y sub 0, z sub 0 with direction vector v, which is equal to abc, is of the form L of t is equal to x sub 0 plus at, y sub 0 plus bt, and then z sub 0 plus ct. So the point of tangency which lies on the tangent line is the tip of the position representation of the vector r of 0, which is equal to 0, 0, 1, which is the point 0, 0, 1. So what it means is that we can use for a point na pwede natin ma-represent yung line tangent to the graph. What we can use is the point of tangency. And the point of tangency is the tip of the position representation of the vector from t is equal to 0. So what we can do is to substitute t is equal to 0 sa r of t and then use its tip, which is yung point na makukuha natin. So we have here r of 0. So solve natin. Yeah. r of 0, which is equal to ln of t plus 1. So that is equal to 0 plus 1, which is 1. For the second component, we have 0 minus sign 3 times 0, which is 0. So we have negative sign of 0. Then for the last one, we have e raised to 2 times 0, which is equal to e raised to 0. And therefore, we should get ln of 1 is equal to 0, a negative sign of 0, which is 0. Okay, and then e raised to 0, which is equal to 1. So, yeah, so we have r of 0, which is 0, 0, 1. And then we can use its tip, which is the point 0, 0, 1, as the point that representing the line. Okay, so for the next one, we have the vector r prime of 0 indicates the direction of the tangent line. So to solve for this one, we have to find the direction vector, which is r prime of t, and then substitute t is equal to 0 to the r prime of t para makuha natin yung direction ng tangent line. So we have r of t, and then for r prime of t, we have to differentiate every component ng r of t. And therefore, we have the derivative of natural log of t plus 1 is equal to 1 over t plus 1 times yung derivative ng inner function, which is equal to 1. Okay, so for the second component, we have the derivative of t is 1, while the derivative of negative sine 3t is equal to negative cosine 3t times yung derivative ng inner function, which is equal to 3. Okay, for the last one, we have e raised to 2t times yung derivative ng exponent, which is equal to 2. And therefore, we have the following. So, and then substitute natin yung t is equal to 0 dun sa nakuha nating r prime of t. And we have 1 over 0 plus 1. For the second one, we have 1 minus 3 cosine of 3 times 0. And for the third one, we have 2 times e raised to 2 times 0. And we have 1, negative 2, and 2. Therefore, a vector equation of the tangent line is, so let's solve it. Ang nakuha natin point kanina is 0, 0, 1. And then we have this r prime of 0. So, yung L of t natin is equal to, okay, so L of t natin is equal to, yung point na nakuha natin dito, which is 0 plus, nakuha natin first component ng r prime of 0, which is equal to 1. Then multiply sa t. So, we have 0 plus t. For the second component, we have 0 again, plus, we have the second component here, which is negative 2. We have negative 2 times t. Then for the last component, we have 1 plus yung nakuha nating last component sa r prime of 0, which is equal to 2. We have 2t. And therefore, we have the following. 0 plus t is equal to t. 0 plus negative 2t is equal to negative 2t. And then we have 1 plus 2t. Okay, so for the last problem, we have okay, so evaluate pala r of t dt from 1 to 2, where r of t is equal to 1 over t e raised to t, and then 2t minus 3t squared. Okay, so for the solution, we simply apply the definition of the definite integral of a vector valued function. Okay, so we have the integral of its components. So we have here for the first component, the integral of 1 over t dt from 1 to 2. Okay, for the second component, we have the integral of e raised to t dt from 1 to 2. And for the last one, we have the integral of 2t minus 3t squared dt from 1 to 2. Okay, and we have the derivative of 1 over t dt is equal to the natural log of t, which is from 1 to 2. For the second component, this is equal to e raised to t from 1 to 2. And for the last one, let's solve it further na lang. So we have 2. So 2t dt. Okay. And then we have negative t integral of t squared dt. And this one is equal to So, recall natin yung power rule. We have t squared over 2. And then, for the second one, we have 3 t cubed over 3. And ma-cancel yung 2 here and yung 3 dito. And therefore, we have t squared minus 3 t cubed. And definite integral siya. So, we have bounds from 1 to 2. Okay, so, yan. And then we have natural log of 2 minus natural log of 1. We have e squared minus e. And then we have 2 squared minus 2 cubed minus the quantity 1 squared minus 1 cubed. And yeah, so for the first component, yung natural log of 1 is equal to 0. So therefore, we have natural log of 2 na lang. For the second component, that is equal to e squared minus e. For the third component, we have 1 squared minus 1, which is 1 cubed, which is 0 na. So we have na lang yung 2 squared, which is 4 minus 2 cubed, which is 8. And therefore, we should have negative 4. And we have the final answer here.